a special case of lossless condition is when R equal to 0, when R dash is equal to 0 is lossless. But then copper, no matter how good a conductor is not a superconductor. Even copper has losses in it. And because of that, your R dash is not 0, and that's the killer. That's going to create losses in the signal. Similarly, dielectric losses in the dielectric material, losses in the dielectric material is going to lead to a G dash, which is not 0. So again, a special case when there are lossless, R and G are 0, you get alpha to be of this form, J omega L dash C dash. You notice that immediately there is only an imaginary part. The real part is 0. This is alpha plus J beta, right? So this alpha term is 0, and your beta is this term here, which is omega square root of LC, L dash C dash, omega into square root of L dash C dash. In other words, for such a lossless case, you can go ahead and see how the plus Z traveling and the negative Z traveling waves look like. The alpha term is 0, so e power alpha Z is 1. And then you can figure out that the phase velocity with which a certain phase, a constant phase, you see that how the phase velocity turns out to be 1 over square root of L dash C dash, which is also the same as the same phase velocity that we saw earlier. So this is in terms of the dielectric constant. This is in terms of the per unit length parameters, the R, L, C, and G. Both are consistent. This is based on the distributed circuit effect. This is based on the real physical material. And the characteristic impedance is square root of L dash over C dash. That is the characteristic impedance. So how do you find this L dash C dash? Depending on the geometry, there are people who have gone and done the analysis to find what is RLCG for different geometries. And once you do that, there are also some software tools where you can draw the PCB or you can draw the multi-layered PCB and find out what is RLCG. Once you find that, you can find your alpha, beta, and Z naught. Alpha should be as close as possible to 0, then it's a lossless transmission line.